Hi, everybody. I think we are about ready to get started. Thanks for joining us today. This is our first Zoom webinar, so expect technical difficulties here. And somebody on my team, please shout out if my slides or screen look funky. But again, thanks for joining this special little asset tracking webinar brought to you by Blues Wireless and Datacake. So today we're going to dive into a really easy way of getting up and running with an asset tracking IoT solution that, again, while really easy to start, I think you'll find is very configurable, very power conscious, and cloud connected. And there we go. So I do want to start with a quick round of introductions, starting off very self-serving, but my name is Rob Lauer. I'm Director of Developer Relations here at Blues Wireless. Far more importantly, with me are TJ Van Tol, who's our Principal Developer Advocate, and Simon Kemper, who is co-founder and CEO of Datacake, and Paige Niedringhaus, who is a staff software engineer here at Blues. Now, together, we're going to provide what I hope is a very informative and certainly an engaging journey for you all today. And I thought it would be nice to start with a quote, and that quote is, "Complexity kills. It sucks the life out of developers. It makes products difficult to plan, build, and test." Now, this is from Ray Ozzie, the Blues Wireless founder and CEO. And I think you'll find today that this theme of simplicity, effectively, killing complexity, runs throughout what we show you both on the Blues Wireless side of things and with Datacake as well. But don't take my word for it. Let's kind of kick things off here. So we're going to kill complexity, if you will, in the asset tracking world in the following ways. So in the moment, I'm going to start with a very brief introduction to Blues Wireless and our core products that make up our asset tracking solutions. TJ is going to join and show off a hands-on demo of setting up an asset tracker from scratch without using a host microcontroller. And then Simon's going to show off the amazing capabilities of Datacake, along with some really great new mapping features. And as a bit of an interlude while TJ runs an errand with his tracker, and you'll see what I mean by that, Paige is going to join and tell us about her all-too-real experience with building and deploying a tracker in her parents' car. And finally, we'll come back to TJ. We'll check on him wherever he may be. Some final logistics. We will be doing some Q&A at the end, but please don't wait until then to ask your questions. There is the Q&A option that you have in your Zoom UI that you can use. Otherwise, there's the chat as well. Either is fine for us. We are certainly all here to answer your questions as they come in during the webinar. So feel free to enter them as they pop into your head. And of course, if anything happens with webinar feed, or if you need to leave early, rest assured we are recording this and we'll provide a link to the webinar on YouTube in about a day or so. And you will get a follow-up email with the recording and some additional resources. So I did want to start with the company that three of us work for, Blues Wireless. And I apologize to those of you who have heard me give this intro before, but I think it is important and gives some context to what Blues can provide in these asset tracking scenarios. So Blues Wireless is an IoT company. We're focused on making wireless connectivity easier for developers, if I can state it in its most simplest terms. As mentioned, we were founded and currently led by former Microsoft Chief Software Architect Ray Ozzie. Ray is well known for starting up Azure back in the day and was a key figure in Lotus Notes. So we do provide hardware and services that back up this message of making wireless IoT easier for developers and more affordable for all. So if that is our core mission, how do we really make that happen? Well, our focus really is on securing your data from the moment it's acquired by a sensor or anything on the device, all the way through to landing on your cloud app. And all of our hardware solutions are low power out of the box to the tune of about 8 microamps when idle. This is, of course, critically important for asset tracking scenarios. And we're also very much a developer-focused company. Our developer experience is absolutely a top priority, hence what I think you'll see is a very elegant and easy-to-use JSON-based API. I could use the phrase low code here today, but I think you'll see that our trackers are configured only with JSON requests, so there is really no coding required. Now, zooming in on our hardware really quickly, the note card is the core of what we provide. It is a low-power system-on-module measuring a tiny 30 by 35 millimeters. It does have that M.2 edge connector at the bottom for embedding in your project. To be clear, there are both cellular and Wi-Fi variants of the note card. the Wi-Fi having the black PCB and the cellular the green. The cellular, of course, includes a GPS module as well, slightly important for asset tracking. It also comes prepaid with 500 megabytes of data and 10 years of service included. So the API, the way you interact with a note card, is all JSON. There's no archaic AT cellular modem commands to manage. And we also have SDKs for Python, Go, Arduino, and C or C++ as well. And there are cellular note card varieties that work globally using NB-IoT, LTE-M, and Cat1 cellular standards. This, again, is a critical feature for asset tracking, especially if you don't know which cellular protocols are available where your asset is heading. So the note card can seamlessly switch between available protocols. Now, to make it easier to use your note card when you're prototyping, or even when you're ready to embed in a more permanent solution, we provide a line of products called note carriers. Now, these are development boards that allow you to snap a note card in and really connect it to virtually any solution you can dream up. For example, the Note Carrier AF includes a feather-compatible socket with onboard antennas as well. The A model includes headers that let you hook it up to any microcontroller you want. It also has onboard antennas. A new rev of this note carrier, I believe, is what TJ is going to be showing off today. The B is a small form factor note carrier. This is great for more production-ready scenarios. And finally, the Note Carrier Pi is a Pi hat for working with really any Raspberry Pi compatible single board computer. And finally, Notehub is the Blues Wireless cloud service that receives data as a proxy from the note card, and in turn will securely route it to your cloud app of choice, which today, of course, is Datacake. Also within Notehub, you can manage fleets of devices. You can update both host microcontroller and note card firmware over the air. And again, Notehub is about securely transmitting data both from the note card and then onto your cloud. And I mean secure as in data is transferred off the public internet via private VPN tunnels and can optionally be encrypted even. There is no certificate management or key rotation required with note card or Notehub. The cool thing about the note card is it knows exactly where to go as soon as you power it on. So again, everything is JSON in and JSON out with the note card API. For example, if you wanted to get your note card's GPS location, you simply call card.location, and it will then return the requested GPS location with some additional metadata. Now, the rest of our API is very similar to this, which TJ will show you off in a little bit. Now, to kind of help visualize where the note card and Notehub sit in your IoT solution, I just want to walk you through a quick diagram here. So you bring your own microcontroller, your own single board computer, or like today, maybe even you skip this step. You use your sensors, your programming language. You're going to compose packets of JSON data that we call notes. This, again, in our case today, could be automatically created. These notes are then queued on the note card, and then at a cadence you specify, they are securely synced with our cloud service Notehub. Now, we don't want your data to live on Notehub. We want you to route that data to your cloud app of choice. So this could be the big clouds or IoT platforms like Datacake, of course. And now I wanted to show this off because while today we're going to focus on building a tracker without a host microcontroller, I want to make it clear that if needed, you absolutely can include an MCU if your solution's needs are more complicated. And I did want to mention too that communication with the note card is bidirectional. So you can start on your cloud app. You can send a JSON-based request with Notehub using the API we provide. Notehub will securely deliver that JSON payload to a single note card or a fleet of note cards. The note card will then deliver it back to the host. So you can really see how you can handle like remote control scenarios or update fleet variables all remotely over cellular or Wi-Fi. In the case of a host-driven asset tracker, you could easily update configuration variables remotely while the asset trackers are already deployed in the field. So I kind of danced around asset tracking in all of these slides. I did want to narrow our focus just a bit here and really get to the value of using the note card and note carrier when building an asset tracker. What you see in the image here is literally all you need to build a simple tracker. Granted, that LiPo battery you see is even probably way bigger than you need. I'll let TJ explain some of the details here, but just to kind of recap where we're at. With the note card, you do get global cellular coverage. which includes 500 megabytes of cellular data and 10 years of service. Again, you can build a fully functional tracker with or without a host MCU. As TJ is going to show you too, you can even add an external BME 280 sensor, and the note card will automatically pull in temperature, pressure, and humidity data. And this even works without a host. Again, critical for asset tracking solutions, the note card is low power by default, meaning the firmware defaults and the hardware. You can, of course, configure the note card to sample GPS location and relay data to the cloud as frequently or as infrequently as you want. Most of you probably know GPS is a massive power hog, though, so be aware. Okay, with that high-level summary, it's probably a good time to see some of this in action. So I do want to hand the controls over to TJ for his demo of building a tracker. So let me stop my share.
Yeah, we're going to have some fun. So let me bring up my screen. And so we're talking about building an asset tracker today. So we were thinking as we were planning this out, what better way to show off an asset tracker than to actually build one and send one out. So my plan for today is to take this note carrier and note card that I've got set up here. So this is really exactly what you'd get from a development kit from Blues that I've got set up. I've got this with basically factory default settings. I've reset everything so that you can see how simple it is to build an asset tracker with the note card from scratch. And then if all goes well, I've got my car keys here. I'm actually going to go take this out so we can start to see some actual data coming through so you can actually see the full process. But first things first, we have to set this up. We have to configure this as an asset tracker. So you'll see I have my note card, my note carrier. I also have this plugged in through a micro USB cable. And the other end of that cable is attached to my laptop that I'm using to join this webinar on. And once you have that connection made, the first thing you want to do is head to dev.blues.io, which is our development hub for really all things Blues. And you'll want to head to the note card playground. Now, what this section of the site will allow you to do is actually connect directly to a USB connected note card and note carrier and send commands directly in your web browser. So as an example, I could send a quick card.version request, again, a fully JSON API to my note card, the note card that's sitting on my desk, and get a response back, in this case, with some basic metadata. The browser is really the easiest way to get started just because it's quite literally as simple as plugging it in and sending some JSON to the note card. I do want to note, though, that all the requests that you're going to see me sending through the browser is something you can also do through our CLI that's available for Mac, for Windows, and for Linux. And as Rob mentioned, if you are using an MCU or a single board computer along with the note card, you can also send these requests through our SDKs that are available for Python, for Arduino, C, C++, and Go as well. So you have lots of different options, but today I'm focusing on simplicity, the simplest way to get started. And I think the browser, dev.blues, and our in-browser terminal is really the easy way to get up and running. So I've got everything hooked up. To set this up as an asset tracker, there's actually only 3 requests that I need to send. The first of them is called hub.set. Now, out of the box, your note cards know how to speak with Notehub, which is, again, our sort of thin cloud backend here at Blues. So on Notehub, you'll need to create an account and to create a project. So in this case, we've already set one up here for our webinar today. And you'll see that each project in Notehub has an identifier, what we call a product UID. So this right here, this identifier maps to what I provided here. And essentially, by doing this, by providing this hub.set, you're essentially linking your physical note card with the cloud service so that you can easily send data that you collect on the note card up to Notehub, where you can view it or send it to some service or do whatever it is you want to do with it. Now, there are some other arguments that I'm providing along with this, the first of which is a mode. So you can connect to, the mode is really like a cellular mode, how often the note card is communicating with a cellular network. It can do so, the main 2 ways are either periodic or continuous. And for the purposes of an asset tracker, you almost always want this to be a periodic connection, mostly because in asset tracking scenarios, unless you have a sort of interesting use case, normally battery power or whatever power you're using to drive this is kind of important. You don't want to use battery unnecessarily. You want your tracker to last as long as possible. And as you'll see as we go throughout some of these modes, the note card has several features built in to try to make that as easy for you as possible. We really try to be really power conscious with everything you do. So in this case, I'm saying only connect to the two cellular networks periodically, and these outbound and inbound control how often that connection should be made. So outbound is saying if the note card has any data on it locally, connect every 60, this is minutes. So every 1 hour, if the note card has any data, it'll make a connection, it'll send that data up to Notehub. Inbound is in the opposite direction, if you remember Rob's diagrams from earlier. So if there are any settings or configuration in Notehub that need to be pushed down to the note card, this 720 is every 12 hours, the note card will check for this. So when you're setting up your own sort of asset trackers, you can tinker with these values depending on what you need, but we find that outbound of 60, inbound of 720 is a pretty reasonable set of defaults. So that's what I'm going with for now. All right, I said 3 different commands. The first was hub.set. The second one I'm going to go ahead and copy so you don't have to see me typo it. And it's card.location.mode. Now, this request is essentially your GPS configuration. It's going to configure how often you're actually taking GPS readings. You'll see that there is, again, a mode for this, periodic or continuous. Again, you're probably always going to want to set this to periodic. GPS is especially sort of power hungry, I guess you could say, to get a signal, GPS signal and such. So usually you want to do that periodically, really almost always you want to do that periodically. And how often is controlled by this seconds arguments. So in this case, seconds of 3600 says essentially take a GPS reading every hour. So I'm going to set this up as a default for now. And I said 3 commands, so I'm going to grab the third one, which is card.location.track.
One other thing I would add, sorry to interrupt you, TJ. One other thing I would add to that second command is that the GPS is only going to enable itself if it detects movement. So there's an onboard accelerometer as well.
Yep.
So just as another, yeah.
I was getting to that though, Rob, because I was going to say, you ruined the whole flow. Because I was going to say,
oh, shut up.
You're fine. The built-in accelerometer is nice. It's another battery feature because, again, you don't want to engage that GPS unless you really need to. There is, though, in this third command, a heartbeat flag. So because if my note card is just sitting here for hours and hours at a time, it doesn't phone home, you might want it to actually check in periodically. And that's what this heartbeat flag is for. So essentially, this hours controls how often that happens. So even if the note card hasn't moved, it hasn't went anywhere, every 12 hours, still take a reading, still send that up so you can make sure everything's working correctly. Maybe you want to check battery levels and whatnot. And again, something you can configure based off what you're doing. This start flag is what actually starts the tracking. So actually after running this command, I've already got a fully functional asset tracker. If you were building this around like an MCU or a single board computer, you might want to play with this start argument. There's a stop argument as well. Like you might want to have some logic that says start tracking under these situations, stop under these. Maybe there's only certain areas you care about or certain situations. So that's something that you might want to tinker with. But for most standalone trackers, like what I'm building here, usually you want to keep things simple and just get things started. And actually, that's it. Like at this point, this tracker that I've got sitting here is ready to go. I basically can just plug a battery into this. I can walk out the door and I will start taking readings according to the variables that I set here. And if you look in Notehub, if I go into this project, you'll see that my device is now going to be registered. You see it checked in here just a minute ago. And if I go to my events is where I'm going to see the data coming from my device as it comes in. So right now I'm just seeing some like basic metadata from when it initialized. What I'll see over time are these track.qo events. These are the events that are actually going to show, if I go into the JSON here, I think I clicked the wrong tab. If I go into the JSON, I'll actually start to see the latitude and longitudes that are reported from GPS readings. And Rob and Simon are going to be taking that and doing some interesting stuff with it later. But I don't have any of those track.qo events coming in yet for this device that's sitting on my desk because I set these values to kind of like more production ready values, like taking a reading every hour, talking to a cell network every hour, which is probably what I might want if I'm getting ready to actually send this hardware out into the field. But for demo purposes, or even for your own sort of internal, like as you first get your hardware and you want to test it out and see it working, Usually you want to crank these down to lower numbers just to see everything working. And I definitely want to do that for a demo. So what I'm going to do is I'm going to run through these commands one more time with some more demo-friendly values. But instead of doing it in the browser, I want to show you another way that you can sort of initialize your note cards with a set of tracking commands. So I'm going to disconnect from my browser, and I'm going to bring over Visual Studio Code, where I've got the note card CLI up and ready to go. So I've got a Mac. This is the Mac version of the note card CLI. You could also do this on Windows or Linux as well. And one cool thing the note card CLI allows you to do is there is this setup flag that lets you point at a file that you can put a bunch of different note card requests that you want to run in sequence. So in this case, a lot of these commands are going to look really similar to what I just ran, but I'll quickly point out what differences are there. So first of all, I'm going to start with a card.restore. This is essentially a reset for the note card. So if you want to make sure any settings, any caches or whatever that were on the note card before, it's a great way at the start of the script to sort of clear those and make sure you're truly working from a blank slate. I've got my hub.set command. This is the same thing I ran in the browser, other than I cranked the outbound way down to every 5 minutes because I want to be seeing data frequently, have things actually show up on a map. Card.location.mode, same thing again, other than I cranked the seconds way down. So we're going to be taking a GPS reading every 30 seconds, assuming I can find some good signal as I'm out driving. Card.aux, this is leveraging the fact that the note card has a built-in way of reading from auxiliary, which is a hard word to say, devices that you can attach to a note carrier. And this specific one is essentially configuring this note carrier to work with, and if you look at my camera for a second, a BME 280 connector, and I've got it connected to this other note carrier I've got sitting here through this JST, or through a quick cable actually onto the note carrier that I'll be using. And I'll show where this is in the docs, but what's cool about this is also going to allow me to get temperature, humidity, and air pressure readings as I'm out getting location data as well. And the rest of this should look familiar. This is card location.track. This is exactly the same as we had before. Start up the tracking, and then I'm going to sync everything to Notehub. So I'm going to go ahead and run that. And while it does, I just want to, as a very last thing, point out where you can find this information on the documentation. So if you're going through this later, you have some hardware and want to set everything up, you want to head to the guides and tutorials section on dev.blues and find our guide to asset tracking. This is a really thorough guide and tutorial that goes through really exactly what I showed today. If you look here, you'll see a lot of where I got my demo from for how to use this setup command, what these different requests that you can send to the note card actually do. There's some additional information. If you want to work with a host controlled tracker, you want to set up some sort of MCU, a single board computer to actually talk to the note card, you can follow this documentation to do that. And I also wanted to show just very briefly the reference documentation. So if you wanted to learn more about the different requests that I was sending, like card.aux or these card.location requests are all in here as well. The reference docs are a great way to just see how the APIs work. And all right, so my config worked. You can see it just runs through these commands in sequence. So at this point, I've got this note carrier. It's ready to go. I've got a second one here that I got pre-configured as well. So this is the same essential thing. I've got a battery hooked up to this, and I've got the BME 280 ready to go. So Rob, if that all looks good, I am actually going to hit the road. And assuming that goes well, that Notehub project that I just showed, so we saw the events, but we didn't see any tracking events. If the demo gods are with me today, we'll start to see those fill up with some actual location data that we can look at.
Fingers crossed. All right.
Fingers crossed. But I think for then, I think we're going to turn it over to Simon so we can get started on some dashboarding stuff.
Yeah. All right, Simon, you're good.
Yeah, okay. I just wanted to ask if I'm already on the screen because I'm not, I couldn't see if that already has happened.
Yep,
so
good.
Let me, first of all, share my screen. And yeah, that should work now. So yes, thank you very much, everyone, for being here, for giving me also the chance to participate in that webinar. That was a great idea. And thanks everybody for joining. First of all, TJ, before, I'm not sure if you already left, but maybe if you're there, just to make sure we need the route set up. So I think, Rob, you have access to his project that we can.
We're all good there.
Okay, great. Just, yeah. Just checking. So yes, let me first of all, I think that most of you who are here on the webinar might know Datacake and what we are doing, but I would like to give you a short introduction. Blues Wireless is the hardware side and also the middleware side that makes sure that your hardware is connected to the cloud and that you can use it. And then you are needing like an end application to use this data to present it to your customers. And this is what basically an IoT platform does. It collects data, it stores the data from devices on databases, and allows people to access the data. You can show things to customers, and Datacake does that in a really easy way, in a low code or no code way. And we're super focused on making IoT, as you can see here, accessible to everyone. And we have various integrations for LoRaWAN, but also for industrial IoT solutions. Check out our website to see. And today it's all about asset tracking. And asset tracking works great with cellular devices such as the Blues Wireless ones. And so I would like to start now, and then let's connect TJ's node card directly to Datacake. And we are going to start from scratch. We have set up a project already for this webinar, and you can see here there are 2 devices in there. And these are backup ones, and also that we set them up a few days ago, so they recorded some kind of data. The first thing that you need to do on Datacake is you need to sign up. So that means Datacake, let me look out once more. Datacake that's not what that's the live thing. I signed off a couple of times that it didn't happen, and now it's because we're live here on the webinar. So Datacake is cloud-based, and it's a cloud-based solution. It runs on servers, and everything is, you need to sign up with your email address. Sign up is free. And you can then, after you have signed up, simply log in. This brings you to a workspace. A workspace is where you hold all your devices and where you can do stuff like creating dashboards and so on. We have set up this workspace here already for the webinar. And what we are now going to do is we're showing you how easily it is to create a new device and bring that node card to Datacake. So as you can see here, there's a button which means add device, which says add device. And if we click on that, that will bring up the modal where you can select the various device types. And because we're adding a generic device to Datacake, we are selecting API. And one of the things that we do for our customers is we try to make adding new devices as easy as possible. And we came up with the idea of providing templates. So once you create a new device, there are some templates available in here. And under the API section, there's also new product from template. And when you click on that, you can see that we do have a template for Blues Wireless node cards. And this one is actually a template that works with the Blues Wireless asset tracker mode that TJ's node card currently is running on. And we're going to select that. And then once you selected the template, you are ready to go to the next step. And in the next step, we're asked for a serial number. And in this case, we would need the serial number from the node card from TJ. TJ was so friendly and sent me the serial number before, so I can just paste it in here. That's the serial number from TJ's device that we just saw. And we are using this serial number because we need to make sure that the data that is sent to Datacake from the Notehub needs to be routed onto a particular device. And that's why we need this serial number. So I just have to give it a name like TJ's node card number 2, because there is already one in here. We press on next. And last but not least, you're required to select a plan. For every new customer that we have on Datacake, we support free devices. So we can start right away. You can just register, try it out with different kinds of devices, and then select the free plan, for example. And we allow adding up to 2 free devices to Datacake. Then you press on add one device, and this will bring this TJ node card 02, what we just created here, into Datacake. Let's open this up. And as you can see here, it already comes with a dashboard. So that means that the templates we are having are bringing you a dashboard already. This dashboard is, of course, user definable. So that means you can just, tweak it or change some settings or add additional widgets. But this is making sure that once you started with Datacake and with the note card, it brings all the necessary things, in here. So the next thing that we need to do, we need to hook up the Notehub, which you just saw on the video before, to Datacake. And we are doing this by providing a link that that Rob will enter on the Notehub. So we go into the configuration on the device we just created. And when we scroll down, you can see various things here like configuration. You can change the name and also provide a location description. And if we scroll down a little bit, we come to the HTTP payload decoder section. This also is completely pre-filled. So that means that this piece of code here is executed every time there's a new message. So, and we decode the data coming from the Notehub. You can ignore this at first, and the most important thing here is this endpoint URL. So this is a URL that we've created on our backend, especially for the product and device we just created. So this means that this is the URL which we need, and this needs to be entered on the Notehub. So I'm going to copy this now, and now there's the question on how to send this to Rob, but I think if I stop sharing my screen, open up the chat in here, paste it. I hope that Rob can see it. And now we can switch to Rob maybe, so Rob can show you what you need to do with that URL on the Notehub.
Absolutely. So I'm actually going to do this opposite. I'm going to set up the route just so we start getting TJ's data through to Datacake as soon as possible. It's not copying from Zoom here. Let's try this again.
I could just read it, but I think it's...
We're good now. And okay, so I am going to... I'm going to share TJ's face again here. So I did want to talk about routes really briefly before I show you them in practice. So TJ is obviously out in the field gathering data with his tracker. We've got that Datacake project set up. So the last thing we need to do is to link that note card to Datacake through Notehub. And this is accomplished, of course, with routes in Notehub. So a route allows you to sync data in near real time with any cloud provider, of course, like Datacake today. Recall everything about Notehub is secure, so meaning that the cellular data TJ is transmitting is actually sent off the public internet, can be encrypted as well. And Notehub also allows you to optionally transform your data on the fly with something called JSONata. This is actually, I'm going to talk about this. It's a cool capability of Notehub, but it's actually one advantage of Datacake. If you saw that HTTP payload decoder section that Simon showed off, that you can do all the transforms there. I still wanted to show an example of what this is like in Notehub. So again, while Datacake can do all of these transforms for you, I at least wanted to touch on JSONata here, as it's I found it to be a very powerful tool that not many people are aware of. At a high level, it is a declarative language for transforming JSON data. That basically means you can take big giant chunks of JSON and you can apply some JSONata magic, and then you end up with a new set of JSON that is trimmed down, optimized, maybe even had some calculations run on individual data segments. So here's an example JSONata transform that you might use in Notehub. I like this example because it shows off a few different capabilities. So you can perform a simple calculation. Like in this case, we're taking a timestamp of when the data was gathered on the note card. So when, that word when comes from, it's a data element in the event in Notehub, and then just multiplying it by 1,000. This next one is great because it provides the ability to conditionally include data. In this specific example, we're asking if the location data came from the GPS module on the note card. If so, use it because that's very accurate. If not, if GPS was not available, then the fallback is the cell tower location where the data was sent. So this provides a really great backup location, for instance. And I think Simon actually includes this in the template on Datacake. Here's an example of just retrieving a data element within the original JSON data object. And at the end here, another simple calculation that allows you to see the difference, so the time difference between like when the data was gathered on the note card versus when it was synced with the cloud. There's also a great JSON playground available that lets you take some raw JSON data. You can test out your JSON transform and then see the results for yourself. This is all available at try.jsonata.org. So with that, I want to show you how to actually route data from Notehub to Datacake. So let me share my browser now. And should be this one. So again, TJ's on the road. Let's see what we've got here. So we do see TJ's latest device, 1034. That was 2.5 minutes ago. So he is getting some data. Let's browse in here and look at specific events that have happened recently. So we do provide, a way to actually see the raw data that's coming through on Notehub. But to be honest, this is not where we want you to spend your time. Like, we want you, I've repeated this a couple of times, we want you to take this data and send it somewhere else, which is where the routes come into play. So we do provide the capability of creating any number of different types of routes. So if you're using a big cloud or you're using like MQTT, something like that, all those capabilities are baked in here. For Datacake, it really couldn't be any simpler. You're just going to create a general HTTP HTTPS request response route. So this is a webhook, this is a RESTful endpoint, anything like that. And at the beginning of my segment, when Simon was done, I did create a new route. Literally all I did was I named it and I pasted in that endpoint URL that Simon provided. Everything else here is boilerplate defaults. Now, if I needed to apply some authentication headers, for instance, I could add those here. If I wanted to rate limit to only, if I didn't want to blast my endpoint with too many requests in too short a time, I could do that. You can manage which devices actually route data through fleets. So if you have fleets of devices set up through Notehub, you can specify which fleets have data routed. You can also specify which note files. So these are remember I talked about how when you queue data up on a note card, it's stored in notes. Well, these notes are in note files. In our case, everything's in a track.qo note file. So if I only wanted to specify certain data to be sent on to the cloud, I could do that here. And finally, there's an opportunity to add different transform options as well at the bottom. This is where the JSONata comes into play. But again, with Datacake, this is all thrown aside because it couldn't be too much simpler than just pasting in a URL. So that, I think, is the end of my segment. We are going to take a little bit of an interlude and head over to Paige now and let TJ keep accumulating some data and then come back to TJ in about 5 to 10 minutes. All right, Paige, go ahead.
Thanks, Rob. So as everyone knows, I haven't said much up until now, but I am one of the hosts of this webinar. And the reason that I am is because I had a Blues note card that was functioning as an asset tracker, and it became the star of a carjacking the day after Thanksgiving when I was visiting my parents. So to give you a little bit of background, I am actually a web developer, first and foremost, not an IoT engineer, not a firmware person. I build websites. So I help build the dev.blues website. I help build Blues.io and various things like that. So what I was actually doing was using a note card to gather location data and see how easy it was to take that data from Notehub and to display it in my own custom built dashboard. I was building a dashboard using React, some charts, some maps, things like that, just to see how simple it could be. So while I was visiting my folks, I actually put a tracker in their car and we drove around for the holidays to see friends and family, go out to Thanksgiving dinner with my aunt and uncle, things like that. So the day after Thanksgiving, while my parents and I were all having dinner together at their house, their car was actually stolen out of their driveway and the tracker still happened to be in the back seat. And this car is not equipped with LoJack. It is not equipped with OnStar, none of that. So as it was stolen, there was no way of knowing where it was going or where it would end up. It just didn't have that capability. So we called the police and they came over, and they actually came over really quickly. So as I remembered that this was in the back seat, I pulled up my locally developed dashboard on my computer, and I was able to show them on the dashboard map where the thieves were as they were heading away from our house at high speed. So here's the interesting point number one that happened while this was going down. When the car was first stolen, the note card was reporting its location every 10 minutes. But as Rob mentioned, you can actually remotely configure note cards via Notehub to update their environment variables. So probably 15 minutes after this happened, one of my coworkers was able to hop on Slack with me, and we actually updated my environment variables on the note card via Notehub so that it would take location readings every 60 seconds. So we could have a better idea of where this car was in space and how fast it was moving away from us. So that was interesting point number one. Another thing that I would like to say is that the custom dashboard I was building was actually using the Notehub API instead of Notehub routes to pull data out of Notehub. So if for some reason you want more historical data that maybe hasn't been routed to a third-party database or something like a low-code platform like Datacake, you can actually use an API-based system with an auth token and pull events out of Notehub, which is what I was doing. So there's a couple of different ways, depending on what your needs are, to actually access that data out of Notehub. So to go back to what was happening in real time, about 2 hours after the car was stolen, and we continued to watch it on my dashboard and through the Notehub events, the tracker was actually found in the back seat and it was tossed out a window into a park. I doubt that the thieves actually knew what it was, but I'm sure that the blinking green LED light on top didn't give them a good feeling about what it was doing. But it survived being tossed out of the car. It survived living in the park in sub-freezing temperatures. And the police actually recovered it 2 days later because I was able to tell them exactly where it was because it kept sending me heartbeat notifications with its current GPS location. So they returned it to my parents. I, by that time, had gone back to my house. So my parents shipped it back to me, and I could follow the note card's tracking through USPS all the way down to when it reached my house. And in the end, the car was found about a month later in an impound lot. It had bullet holes in the roof, a ruined interior, and the heavy smell of marijuana throughout. So it was totaled, as you may imagine. And it wasn't the happy ending that we were hoping for, but it made for a great real world use case. And one more thing that I would like to point out is that while the police were still trying to find the car within the first few days after it was stolen, they knew that I had this dashboard. They knew that I had note card data, and they asked if I could provide them with a spreadsheet of some of the note cards location readings so that they had a timestamp and a GPS coordinates. And I was able to pull that directly out of the Notehub dashboard, just take some filter down to the events that I wanted between the time frame that I needed, and then export that as a CSV that I was able to send to them. And they were going to use that location data and those timestamps to actually cross-reference traffic cams to see if they could see the car as it was traveling around and joyriding. So it was certainly not a great occasion by any means, but I learned some really cool things about what the note cards and Notehub are capable of, and it made for a great story in the end. So, talk about turning lemons into pretty good lemonade, I'd say.
Along with dash cams, everybody needs to set up a tracker now too in their car.
Right.
That's great. Thank you, Paige. Yeah, sorry your parents had to sacrifice a car for a good story for us.
I know. At least they did have something that came out of this that was fairly positive, though.
And it's a good point too. Like we talked about this internally as well. As of course you can set up a tracker to run off a USB power as well, so you can have it perpetually running in a car, for instance, instead of worrying about battery life. So, yeah. Simon, do you want to show off the dashboard? Dare I say we have enough data from TJ?
Yes, sure. Give me 1 second. just thinking of, yep. So I'm now just sharing our browser window. I hope this works. I haven't been checking it, but I think we should receive a lot of data already. So this is where we stopped when we were presenting the Datacake solution. And just to recap what we did, we were using this link, which we just created, sent this over to Rob, and Rob was placing this into the Notehub for TJ's card. And on here, you can see there is this button which says show logs. And if we click on that, we can see all the incoming events over that link, over that URL. And as we can see here, yeah, it was changing already. There is some data, and this seems to be like, yeah, it looks completely like Blues Wireless information from the Notehub. And yes, I think this is exactly what the note card from TJ is sending us. So that means we would now be able to see some data. So let's scroll up, go back to the dashboard in here. And yes, we can see some data. So actually 17 degrees Celsius, 4.14 volts. That means it's, I think, almost fully charged, and good cellular signal to cellular bars. And also we can see the position in here. So if I zoom out, sorry, a little bit, and we can see, okay, TJ is somewhere over here. I think this is TJ's hometown, so this seems to be TJ. I'm not sure if, but you know that he's living there. And we can also switch now. As we can see, this is just like static information, though the current position. What we can do here is we can go into edit mode for dashboards, and we can press on this edit icon, and then we are going to edit the actual widget. And in here, we can select the time frame, and I can select this time frame to hour, and also I could send this back to 1 minute. That means that it now shows us high frequency data and the route that TJ is currently doing, or just walking or driving. We can press on save to save these, and this is now in the widget here. And we can also scroll back and forth in time to see, okay, this was the route that TJ was doing. For all the guests in here, what we can do now also is we can make this public. That means we have a function. When you click on the edit mode here in Datacake, there's this lighter blue button called public link. Sorry, if you click on that, this will open up a modal where we need to click a couple of times once more, and then it creates a QR code which we could download, print on a device, and send this to a customer. Or if somebody wants to do it right now, they can just scan this QR code. And I am also going to share this link into the public chat. That means that everybody can access it now and then also see the dashboard. We save the public link, exit it. Also checking there is a mobile version of this dashboard as well. Yes, it shows data. And yeah, we can just see what TJ is actually doing and where he's going. And this is how we create an integration. I think the longest part is on the Notehub, where you create all the configuration files. It takes about 1 minute or 2 minutes, and then it connects, and then you send the link or set up the link on the routes on the Notehub, and then the data is already there. And thanks to that preset, what we are doing is we make it super easy to start with IoT projects. But as Rob and TJ also mentioned, they are sending extra data like humidity through these additional sensors. When we go back to the decoding in here, we can see also that there is, at some point there was, I think I was seeing it already, there is a couple of data in here somewhere that was humidity and stuff like that in here. So what we could do is we could change, but this extends, I think, the time of the webinar to go down there and how to program this. But what you could do, you can simply change the decoder in here and also decode the data, additional data that is coming from your note card. But basically for asset tracking, we already set up the solution. And in this case, Paige, thanks for your story. And I think that in this case, we could also do like a tracking device directly on Datacake with that solution, and or you could self-program it. But basically, we are storing the data and we can go back in time, and we can also export data. So it would also be possible to share this live dashboard of your car directly with the police, which would be also cool somehow. Yeah. So from the Datacake perspective, that's it. That's how you create or integrate note cards directly into Datacake. And the next steps would be that, yeah, people or customers could create shared dashboard. We also created this small demo dashboard here before the webinar, where we set up all the devices that are in the workspace. And there are 2 backup note cards in here, and they say, yeah, show the same position, or show the position of the note cards. So you could create like global overview dashboards, which you can share with your customers to monitor a fleet. And if you click on one of those, you can see on the sidebar dashboard the data from individual note cards.
Yeah, I think this is really powerful, because a lot of the demos that we do in these scenarios just show off a single device. But many of you, when you're building out a solution, you're going to have 10, 100, 1,000 devices, and to see that all that data in one in one dashboard is really powerful.
Yeah, thanks. There's, I think, let me see if I can access it, because I absolutely share this with you. This is where the use cases begin to make sense. We accessed, thanks to your integration, we were able to pull a lot of your Air nodes directly on Datacake. Air nodes, just to mention, these are small. I can access one, then you can see it. They also have tracking capabilities, but they are static devices. There's no picture, but it's like an air quality monitor from Blues Wireless. And what we've done is to, to show up them, or to, this is actually the device. This is how it's looking. And what we've done is we created a dashboard. I hope this was the correct one, that shows up all of the note cards on a single map. And of course, it's not loading because it's a live webinar. It might be because of the internet connectivity. I don't know. Just let's give it a time. And yeah, there it is. And what you can see here is, you can see this would be a use case if you have a lot of different devices on the Datacake platform, and a lot of asset tracking devices, for example, also, but also static devices. And what we can do here is, these are the various note card positions. And when you click on one, you can see the actual data. We're going to work on updates on new features for this map, where you can blend in the measurement values directly on the map. So also next stages would be heat maps and stuff like that. But it's pretty cool to really see this fleet view, and then select the individual devices, and then see, okay, what's going on with my devices, and scroll back. But that's where, it makes most sense. I agree.
Cool. Thank you, Simon. TJ, did you, are you on the call still? There he is.
I am here, Rob. I don't know how well you see my background. My audio is probably awful too, because it's windy here, but I wanted to go to the one scenic place I probably could around here, and it's the Michigan State Capitol. So,
well, that is where we saw you on the map.
Yeah, awesome.
Excellent.
Hopefully my audio isn't too crappy, but good stuff.
Excellent. So I just have a couple other things to share. I know we're running up on time here. There's Paige again. I was going to mention that a colleague of ours is on a road trip in the southern US. He put together another great Datacake dashboard to track his location, along with some other sensor data. He's actually using some new hardware we're testing out. I don't have much more to say about it at this moment, but needless to say, this should all improve our asset tracking story even more than what you saw today. Also, I want to mention that one resource that all 4 of us contribute to quite a bit is Hackster. So we all have some pretty extensive tutorials we published, including like machine learning use cases, asset tracking, of course, and remote monitoring. You can see like all the scenarios you can address with wireless IoT here. So, you can check out all of our projects at hackster.io/blueswireless. With that, I want to thank you all quickly for attending. But before we jump into the Q&A, there's a few resources I want to share. One is to visit dev.blues.io for all those technical resources that TJ showed off. Also, just for being here, we welcome you to take 10% off a Blues Wireless starter kit or other note card and note carrier combo at bit.ly/bluesdatacake10. And finally, there's a brand new guide on Datacake for using the note card. With that, And yeah, you can see the link there, and I'll include that in the email as well. And with that, I think we can go through some of our questions. And I think I will try, and I know we only have a couple minutes here. A bunch of questions. Let me see here. So a question came in early on: is it possible to connect LoRa sensors to the note card? And the answer is yes. I mean, if you're embedding the note card in an existing solution, if the host microcontroller can speak to a LoRa sensor, then that data, of course, can be sent to the note card. I did want to mention too that when people talk about LoRa, we actually have a new LoRa-based product coming out probably later this spring, early summer, called Sparrow. You'll be able to find more information about it at Blues.io as time goes on. And let's see. A question came in about setting location boundaries and get alerted when an asset is outside of boundaries. And yeah, we do provide geofencing capabilities in the note card API. So you can set up so that you can set up a geofence, meaning like from a certain lat long coordinates, if you get to be like 30 meters outside of those coordinates to immediately send a note to Notehub. So you can have an alerting system set up that way. So it's all available in the API. Is the coverage for note card global? Yes. So there are 4 different note card models. One is the NBGL, which is our global. It's a narrowband global note card that works over LTE-M and NB-IoT protocols. There's also some wideband note cards that work on Cat-M, and those are specific to North America or EMEA. And there's also a narrowband North America one. So we've got pretty good coverage globally. Notable omissions to that global coverage are India and China, just because our wireless partner does not offer service there. However, on almost all of our note carriers, there's an opportunity to add an external SIM card, and you can use those if you need to in unsupported countries. If anybody else saw a good question, to feel free to chime in. There was a question. Oh, Simon, if you want to take this one, somebody's asking if a widget could be shared by secured link only and not public.
Yes, I was already answering it by text, but basically what we do have is that if you enable sharing of a dashboard, you cannot share simply just the widget itself, but you can always share a dashboard, and you can just place one widget on the dashboard. So that would be like sharing just a single widget. What you can do is you can put passwords on the shared link, but once you stop sharing the link, users need to log in. So there's just public shareable links with password protection, optional password protection, or you disable sharing of links and then the user needs to log in. So these are the 2 options that we have.
Perfect. Another good question came in about working on projects in rural areas. Connection can be really bad. That's a very, very valid question. And there's a couple of different answers to that. Like we do offer a Wi-Fi note card. So if you have effectively like a statically placed note card, you could use Wi-Fi as well. Some of our note cards also include the option to add a diversity antenna. So aside from using the regular antenna, you can add a separate antenna and get, I don't want to say double the connection, but a much better connection capabilities with those as well. So we do, and we've seen that as well ourselves. I mean, when you get outside the range of like, big cities, sometimes the connection gets a little bit worse, but with those diversity antennas, you can really take advantage of
yeah, the quality might be crap, but I have one hooked up here, the middle one here, because I found it actually helped with my signal when testing this as well.
Perfect. Let's see. I know we're running on time here. I'm just scanning. Question was asked about customers in the Middle East region. Yes, absolutely. So our NBGL model is supported in the Middle East as well. So you can definitely use a note card there. And
I think I also can answer another question.
Sure.
There is someone asking about further calculations like distances and so are done on Blue's wireless platform on the Notehub or on Datacake. Maybe I could share my screen just very quickly.
Yeah.
That is possible. Yes, there it is. We do have some features for doing that. So that means that you could do it on Datacake. In the decoder we were just showing, it's not just transforming data, but also doing some basic calculations. So what we're doing here, this is actually a public transport API, which we are accessing. So they have some kind of devices. I think they're cellular. Maybe it's also note cards. And what we are doing here is we're having a function. This is called calculate distance. So in that you can just always calculate the distance between 2 points. And we're using that in this map in here. You can see this is also like asset tracking for a lot of different devices. And if we would access one of those devices, no, the window is just holding it back here. But as you can see here, there's somewhere there's a window over it. I can't, there it is. Yes, you can see here we are tracking down the distance. And this is not, we are just receiving latitude, longitude, and we're using Datacake to convert it to distance covered. And if there's more accuracy, so more points per minute or per hour, of course it has higher accuracy. So, but just very quickly on that.
Cool. There's one other question that came in. Just to clarify, the question is about when you're abroad, do you need to pay for data? And no, like the data, the prepaid data and service is global. So you don't have to worry about any additional payments when you take your note card around the world. With that, I again want to thank everyone for attending, and there will be a recording of this coming up shortly. But yeah, thanks to the panelists and thanks for y'all for attending.